For 8.2, you all are going to be combining all of the things that you've learned about scatter plots so far into this one activity. So taking the data from a table, plotting it on your scatter plot, talking about outliers, associations, all that type of stuff. So 8.2, animal brains. Is there an association between the weight of an animal's body and the weight of an animal's brain? As a side note, one of my really good friends, his dad travels all the time for work, and he just told me this past weekend about how he was in South Africa, and their delicacy for dessert is monkey brains. So he ate monkey brains. I don't know how many of you all would do that, but I thought that was pretty gross. Anyway, we're going to use the data in the table to make a scatter plot. Are there any outliers? So here we have all this data, body weight, brain weight. We're going to graph that in our scatter plot on the next page, okay? Once you've done that, you're going to talk about numbers 1, 2, and 3. So number 1, after removing the outliers, does there appear to be an association between body weight and brain weight? Describe the association in a sentence. So I'm looking for you to tell me if it's linear or nonlinear, and if it's positive or negative, okay? So I want both of those things addressed in number 1. For number 2, using a piece of pasta in a straight edge, so in real life, using your pencil in a straight edge, fit a line to your scatter plot and estimate its slope. So you have all your points plotted, now you're going to draw a line through it, and you're going to estimate what the slope is, and then you're going to tell me what the slope means in the context of brain and body weight. And then lastly, number 3, does the fitted line help you identify more outliers? So we're going to do 5 minutes by ourselves, and then 5 minutes with our group, because this is a whole bunch of work that we have to get done, okay? In the first 5 minutes, you absolutely should be able to have all of your points plotted, and you should at least be starting on number 1. The 5 minutes with your group, I really want you to focus on a discussion surrounding numbers 1, 2, and 3. So pause the video. After that 10 minutes of work time, play the video, and we'll go over the answers together. Okay, your plotted points should look very similar to mine. So we've got a whole bunch of data down here, some up here, and then one random thing all the way up there, okay? So looking at number 1, after removing the outliers, does there appear to be an association between body weight and brain weight? Describe the association in one sentence. So the outlier that stands out to me is this one all the way up here, which just happens to be the human. So our brains are way, way heavier than most of the brains of other species that have similar body weight to us, which is interesting. So once we get rid of that, I see a positive association. It seems like as body weight is increasing, brain weight also tends to be increasing. I would also say that this looks linear to me. It looks like a line could, I just dropped my pencil, whoops. It looks like a line could fit this data pretty well. Does everybody see that? Number 2, using your pencil and a straight edge, fit a line to your scatter plot and estimate its slope. So here we have a beautiful already done graph where they have drawn a line through the data. If we were to look at the slope of this line, it seems like the slope is about 1. So it looks like this is a point, this is a point. So we go over 50, 100, 150, 200, and we go up 200, okay? So pay close attention to the units on the sides of your graph. Here we're going by 50s. On our y-axis, we're going by 100s, okay? So if we were to draw a slope triangle here, it looks like the slope is about 200, change in y, over 200, change in x, which would simplify to about 1. So the slope of this line is about 1, which means that for every increase in body weight by 1 kilogram, The model predicts an increase of 1 gram for brain weight. So this slope of 1 means that as body weight increases by 1 kilogram, brain weight increases also by 1 kilogram. So as body weight increases by 1 kilogram, brain weight increases by 1 kilogram. And then that last question, does the fitted line help you identify more outliers? What do you all think? Would you consider any of these other things outliers? I might say that the chimpanzee could be an outlier, this one right here. That data seems pretty far away from the rest of the data points around the line, but everything else is seeming very close to me. Okay?